This is where you pause the video and work these problems out on your own. I'll be back in a second to work them out with you. All right, well, solving those problems for bell ringer, or the bell ringer, I should say. Number 46, 19 plus 32. Notice I wrote these vertically instead of horizontally how they were given. So 9 plus 2 is 11. 3 plus 1 is 4, plus 1 more is 5. So 19 plus 32 is 51. 0 plus 4 is 4, and 9 plus 5 is 14. 50 plus 94 is 144. 7 plus 1 is 8. 8 plus 1 is 9. 1 plus 2 is 3. 398. And 1,149 plus 2,021. 9 plus 1 is 10. Put the 1, bring down the 0. 1 plus 4 is 5, plus 2 more is 7. 1 plus 0 is 1, and 1 plus 2 is 3. 3,170. Now that you've watched that and you've written these down, you should get 100% on your bell ringer test, which some people have not yet done. So go do that. Okay, well, now that you've got the thought of the day done and the bell ringer done, and hopefully you took notes on the bell ringer so you can take that bell ringer check later and get 100% on that. But we're going to start the lesson, which starts on page 4 in your math book if you're following along, and I encourage you to do so. It says the following numbers are integers. So integers start with like -3, -2, -1, 0. So they go all the way down infinitely, okay? And then they go to 0, and then 1, 2, 3, and then this ... means they go up infinitely. So these are called integers. Now, a lot of times when people say integers, students think of just these negative numbers over here, but the integers also include 0, which is neither negative nor positive, and all of the positive whole numbers as well. Okay, so the all of the whole numbers and their opposites. So an example of a non-integer would be 3/4 or -1.5. Okay, because those are not right on these whole numbers and their opposites over here. These are called integers. Whole numbers, on the other hand, will start at 0 and go up. So, for instance, 0, 1, 2, 3, 4, 5, 6, 7, 8. Those are the whole numbers. And when we talk about integers, we now include their opposites, or the negatives over here. Okay, but we're going to talk about absolute value, something you probably talked about in 6th grade. So it'll be nice, quick, and easy here. The absolute value of an integer is the distance between the number and 0 on a number line. The absolute value of a number A, so there's just an example here. We use a variable because we could input any number into that, is written as, and then these two long lines. So they almost look like flattened out parentheses or something, but they're just two long lines. Now you have to be careful when you're using these to write them nicely and neatly, or when you write the absolute value of 4 down here, it would look like 141. So you do have to make these lines nice and long so we realize they're not ones. So the absolute value of -4 is how this would be read. The absolute value of -4 equals 4, because -4 is 4 units away from 0. The absolute value of 4 also equals 4, because it is also 4 units away from 0. When you find the absolute value of a number, your answer can never be negative, because it's a distance, and you can't have a negative distance. So finding the absolute value. Example 1. Find the absolute value of 2. Well, we can use a number line to do that. 2 is 2 places away from 0. So the absolute value of 2 is 2. Maybe you didn't need to use a number line for that. Maybe you're catching on so quickly you've already gotten all this. The absolute value of -3 is example number 2. And it says, find the absolute value of -3. Well, -3 is 3 places away from 0. So the absolute value of -3 is 3. On your own. So here are some problems you're going to do on your own. Well, hopefully that didn't take you too long, but we do still write these down nicely and neatly and organized because that's how we do math, nice and neat, organized. So number 1, the absolute value of 7 equals 7 because it's 7 places away from 0. Or you can just look at this number and drop any sign out front if it has one. Number 2, the absolute value of -1 is 1. The absolute value of -5 is 5. And the absolute value of 14 is 14. Notice all of my answers are positive here, okay? You can never have a negative answer here. There is actually one answer you could get that would not be positive nor negative because the absolute value of 0 is 0. The next part of the lesson is comparing the values. So we're comparing 1 and the absolute value of -4. Now these are the things that we have to write down because this is what we're comparing. But when we're thinking of the absolute value of -4, in our heads we should be thinking, we know what that is, it's 4. Okay, so here they're going to compare those. So they graphed them on a number line, and they graphed, instead of graphing the absolute value of -4 at -4 down here, the absolute value of -4 is 4. So they graphed it right here. On a number line, the further to the left, the less it is. Now, you don't have to think of a number line. That's just one way they're showing this. It's actually not how I would do it. I would look at the problem, and the problem is to compare 1 and the absolute value of -4. Okay, and we're going to put some symbol right here, either the equal to, the greater than, or the less than symbol here. What I would do is I would write down a similar problem. I would keep 1, 1, because it doesn't have to change, but the absolute value of -4, I would just write 4. Well, that's pretty easy. I know that 1 is less than 4. So now I can go up here and use that less than symbol. 1 is less than the absolute value of -4. Now, you go try these on your own. All right. Well, these shouldn't have taken you too long, and I do hope that you're writing them down nicely and neatly. So number 5, we have the absolute value of -2. We know what that is, 2. And -1 is just -1 because it doesn't have the absolute value symbols around it. Well, 2 is greater than -1. So now I go back up here. The absolute value of -2 is greater than -1. For number 6, -7, well, that's just -7. And over here, it's the absolute value of 6. And the absolute value of 6 is 6. I know here that -7 is a colder temperature, so less than 6. Now I take that symbol and I put it right up here. Number 7. The absolute value of 10 is 10. This is just 11. 10 is less than 11. So I go back up here. The absolute value of 10 is less than 11. And finally, on number 8, 9 is 9, and the absolute value of -9 is 9. 9 is not greater than or equal to 9. It's equal to. So 9 is equal to the absolute value of -9. Finally, we have our real-life application example here, and it says the freezing point is the temperature at which a liquid becomes a solid. So if you had like molten gold, please share. But if you have molten gold and it's super hot because you had to melt it down, and it actually forms a solid at a really high temperature. But when it forms that solid, it's actually called freezing because it's turning into a solid. A, which substance in the table has the lowest freezing point? So we look here. What's the lowest number? -53, of course. If these were, oh, they are temperatures. This is the coldest temperature. And then it says, is the freezing point of mercury or butter closer to the freezing point of water, which is 0 degrees Celsius? So which one, mercury or butter, is closer to 0? Mercury, -39, is 39 away from 0. Butter, 35, is 35 away from 0. So we're really finding their absolute values, and we find that butter is closer to 0. So the answer would be butter, which they have right down here. Now there's one problem for us to do. It says on your own. We'll just do it together really quickly here. Is the freezing point of airplane fuel or candle wax closer to the freezing point of water? So airplane fuel, negative 53, and candle wax, positive 55. Which one's closer to 0? Well, we're finding their absolute values, and we see that airplane fuel is closer to the freezing point of water, which is 0 degrees. Okay, so airplane fuel would be the answer to the on your own there.